claim is false. All other combinations of truth values are consistent with the conditional being true. This now gives us the truth table for the conditional. For the sake of consistency and familiarity with the truth tables for the conjunction and the disjunction, I placed the arrow symbol in between the A and the B to represent the conditional operator, where A arrow B means if A then B. The conditional asserts that if A is true, then you can infer B. It doesn't go the other way. It doesn't say that if B is true, then you can infer A. Notice that the second row gives the only combination of truth values that makes the conditional false when A is true and B is false. For all other combinations, the conditional counts as true. Now, this definition doesn't always give intuitive results about how to interpret language that uses conditionals. But for purposes of doing propositional logic, it gets it right in all the cases that matter.
Conditionals are extremely important in the sciences, where they play a central role in hypothesis formation. Here's an example. If salt water exists on Mars, then microbial life exists there. This is clearly hypothetical. How would we test it? Well, we've got the data from Curiosity rover, the NASA vehicle that collected myriad soil and atmospheric samples since 2012. Let's examine the possibilities by testing our hypothesis within the context of the truth table for conditional statements. The antecedent for our hypothesis is the claim that salt water exists on Mars. The consequent is that microbial life exists there. So we'll express this by saying if S, then L, symbolically notated as S horseshoe L. According to the truth table for the conditional, the only instance in which the hypothesis would be disproven or falsified is in the second row, where it's true that water exists on Mars, but false that there is microbial life. If that's the case, then the hypothesis needs to be reworked, since the hypothesis posits that the presence of salt water implies the presence of microbial life. But what if the rover fails to detect salt water but finds microbial life, as in the third row of the truth table? And how about the fourth row, where rover supposedly finds neither salt water nor microbial life? Wouldn't those two rows disconfirm the hypothesis? Not at all. The hypothesis still stands. If salt water exists on Mars, then microbial life exists there. The instances in which we did not find salt water but did detect microbial life, the third row, and in which we found neither, that is the fourth row, does not affect the hypothesis, since it only claims that the presence of salt water on Mars implies microbial life. So the only time our hypothesis is disconfirmed is in the second row, where S is true and L is false. So here's our rule for the conditional. A conditional sentence is false if and only if its antecedent is true and its consequent is false. Otherwise, it's true. Let's add one more general observation about conditionals. We've discussed the distinction between sufficient and necessary conditions in a previous lecture, specifically Unit 5.1. A necessary condition is a condition that must be present for an event to occur. A sufficient condition is a condition or set of conditions that will, in and of itself or themselves, produce the event. A necessary condition must be there, but it alone does not provide sufficient cause for the occurrence of the event. Only the sufficient grounds can do this. Here's an example. Electrocution is sufficient to cause death. However, people can die in many other ways, and therefore electrocution is not necessary to cause death. In any conditional sentence, the antecedent expresses a sufficient condition for the consequent, and the consequent, a necessary condition for the antecedent. Thus, another way of saying if A, then B is to say that A is sufficient for B and B is necessary for A. If I assert that if Maria is a practicing attorney, then she's passed the bar exam, that means that passing the bar exam is a necessary condition for practicing law, and that being a practicing lawyer is a sufficient condition for having passed the bar exam, in the sense that the former is a guarantee for the latter. It's important to appreciate the relationship between sufficient and necessary conditions in conditional sentences because it helps us properly order the antecedent and the consequent in cases where it might get tricky. Take the following example. Maria is a practicing lawyer only if she has passed the bar exam. Here, we might be tempted to translate this into sentential logic with the following. If Maria passed the bar exam, then she is a practicing lawyer. But that would be mistaken. The locution only if clearly indicates that what follows is a necessary condition. As a result, only if introduces the consequent. Of course, if taken by itself, would still introduce the antecedent. Next up in this unit, we'll take a look at the biconditional.